Hello, everybody, and I hope and assume everybody is doing well. For today's presentation, we will cover part two of our CAD to CAM series. Part two meaning last time around, we had done a treatment plan with a patient in need of an immediate upper denture who had number 5 and 13 missing, and we were aiming for a number 2 and 15 extraction. And the plan was to create an RPD with pocketed 5 and 13 and include 2 as well as 15 onto the appliance. Well, the objective was to create 3 separate STL files for production. We used 3Shape 2021 dental systems for this particular case. And from there on, we generated the STLs so that we can import into part 2 using Mailbox by Sim system. For those of you who are a bit familiar with Mailbox, I would like to go over a couple of slides in regards to interesting features as well as options for users out there. The first slide would be the hotkeys. So this information is out there, and I will guide you at the end of the presentation what you need to do in order to get extra information, extra knowledge base for Mailbox and Sim system. So this is just an overview of some hotkeys that we can use during the actual nesting as well as importing of your STLs onto Mailbox. For example, popular hotkeys would be Control+E, which would hide your fixture instead of going through the tools management as well as picking and choosing visual layers. Another popular button is the number 9 button, which toggles the translucency of the actual imported file. So this will be available for you on the Sim System Mailbox website directly. Talking about 2020 improvement, some improvements are out there. One of the more improved aspects is the job report. You will now have a 3D image preview on the report. If you go through the right side of this slide, you will have some interesting notes to it. There's a prototype for usage on a template, one with within one of these extensions, the .doc's, DOCX, XLS, and XLXX. And also there's a couple of new features on the 2020. For example, within the Lab 3D Explorer that every single Mailbox user has, they will have the ability to do thickness analysis. Popular question that we get when a support call comes in is an orientation. So an orientation topic would occur when the STL is outputted within after a CAD system generates that STL and XYZ has a disorientation, XYZ axis has a disorientation. Using the Lab 3D Explorer, with a click away, you will be able to actually change that orientation and import it onto your CAM properly. This is the thickness analysis where you can actually have a preview of that particular STL you'll be working on. Next up on the slides is the denture teeth approach, which with a multi-tooth detection. For example, if you are doing a full arch denture, separated teeth, and you import onto Mailbox, you will have that feature active. The system will actually recognize different separated teeth that will be imported onto your interface itself when you, of course, choose denture teeth as object type. Also, the possibility to move multiple restorations during nesting. You can now use and multi-select parts and move them collectively together. Just a small couple of seconds of video. This is the example. You click and choose these parts, and you will be able to move your STLs around in your disk. As promised at the beginning, I would really recommend for all users to go on to the Sim System USA support portal. You can find all kinds of answers and knowledge base related. and I always welcome all the users to reach out to their CAD/CAM specialist as well as sales specialists in order for them to guide through any kind of sales topic as well as technical conversations. Now, after this presentation, I would like to show you a couple of extra features as well. So we will be jumping ahead with that STL file that we generated during the part 1, import onto Mailbox, and then from there, we would like to go ahead and do some simulations, play around with some features so that you will be much more comfortable seeing what we have discussed and presented. This is our case that we did during part 1. This was done with 3Shape, and as you see, when what we talked about the treatment plan, we got 2 pocketed in these sections, and then we have 2 molars that we added and incorporated onto our RPD. And if I activate both of my denture teeth, you will see clearly that I have the possibility to mill them or print them separately if need to be. So without wasting more time, because I know we are time sensitive here, what we can do is we can jump ahead and we can start off importing onto Mailbox. So for those of you who are a bit familiar with Mailbox or who have Mailbox on trial or even avid users, this is the interface that we use at Zahn, and this is the Zahn Academy Zahn Dental customized Mailbox that you see here. For my first step, what I would do is I would start my new job, and I'm going to choose 52D for this configuration. What I have done on my end, I have actually customized my tool slots in order to get 3 sets. But for this particular demo, we will be using the 52D Zahn Canada multi-tool that I have customized on my end. And as mentioned during part 1, our material is the acetal material that we will be using. So during the demo, you will see some customizable approaches that I have done, and I would like to discuss about that as well. So Mailbox is a software that is customizable, as you may have noticed, and there's a couple of features that may be enabled and disabled from manufacturer, from distributor, and from technical support agents. For this particular case, I have actually customized acetal with its own color, which would be onto brown yellowish. So my case I know for a fact is this one right here, and I'm going to mark it as an RPD framework and go ahead and import it. So once my import is finished, I will be in a position to select the stock within my library. Now I will move forward with a new stock, new disk for this particular case, and I will be choosing a 20 millimeter height on the stock itself. So let's just give a couple of seconds here. And in the meantime, during the features, I will discuss about what you can do in order to just bump up the quality of your production and maximize your result at the end. So as you see, acetal pops up. Since that's the material I chose, I'm going to go ahead and choose add a new one, acetal demo 20 millimeter, and we're going to go ahead and check it. So I have my automatic sprues off, and at the end of the presentation, what I can do is I can show you what dealers as well as manufacturers, sim system can do in order to toggle through enabling and disabling some features within Mailbox. So for this particular case, the first thing that I would do is I would position it in the middle so that I know that I'm safe during the milling cycle. I'm going to bump up my 4 millimeter offset to 5. And then I'm going to start off by analyzing what I'm going to do as far as the milling strategies. So one thing that I would like to emphasize on are really the undercuts, as you see over here in the pockets. So this will be my main focus for this demonstration. The reason why I would like to focus on this particular part as well as the second part, which is this area right there, is because I would want to customize that area with a designated strategy. And how to do this and why is it important? It's because when we use the defaulted strategy, you will most probably have the undercuts as is as a wall. And I have some pictures to show you the difference between designated area as well as non-designated area. How we do this is pretty simple. So on the left side, you got the tools key right here. I will go ahead and I will choose the fourth option from the top, milling zone designation. This will open up a tab on the top. I'm going to go ahead and position my restoration appliance in a way where I'm comfortable with a sight of my undercut view. And the reason why I'm doing this is because once I start painting the zone and selecting the designated zone, it will automatically choose that as an axis of milling. So I will go ahead and start my select operation type. And what I would like to do is I would like to mill it with my smallest, which is the 0.6 millimeter burr, as the rest of the material. So I go ahead and I activate that, and I'm going to simply come in and paint the area. I got two options, or I can activate and enable the fill selection, which I will do now. And what MillBox does is just click and drag in that area of interest, and whatever is in the middle of what I have just drawn will be selected. And as you see, there's an axis that appears. So this is giving the command to use a 0.6 burr at the end of my milling in order to make sure that whatever I have as pocket is milled completely and adequately based on my design. If I do not activate this feature manually, what will happen is most probably you will have some grinding to do and milling to do underneath your acrylic teeth that you saw at the beginning, which are these two right here. So I'm going to jump ahead to the other side, and instead of enabling fill selection, what I will do is I will disable it just by clicking, select operation, rest of the material, and it will give me another option of painting it. So I'm going to start painting around over here, all my zones of undercuts, so that I can make sure that I have a decent coverage with the 0.6 milling tool. I see undercuts over here as well. We can go ahead and paint this area as well for this undercut in order to get maximum milling of this pocket. So once I'm comfortable with these two, I can exit out. And next up would be positioning my connectors. So in order for me to trigger that, I would click on my STL and go ahead with this plus sign. And ideally, I'm going to go ahead and choose the smart pin, which gives me the opportunity to follow my equator line. So why do I choose my smart pin? Because I have some thin areas in the back of my appliance, which I would like to position some connectors. So for example, I'm going to start off in the middle right here, put one there, another one right there. Same thing on the opposing side. And also I'm going to turn my STL around and put one right here. And another one right there. And for these bicuspids, what I would do in order to get some more solidity, I can go ahead and I can change my connector to a circular one. However, I'm going to go ahead and decrease my thickness and increase on my pin diameter at material to 2.5. This will give me a nice solid conical feature so that I have some stability near the anteriors, because I do not want to compromise my design putting an actual pin right there. So what you can do also if you're controlling on the CAD side is when you're finishing your CAD design, you can actually put a vertical attachment right here and incorporate onto your STL so that you can extend it in MillBox all the way to your disc and have more stability if need to be. That's an option as a designer that you can do and move forward with. Now, as far as my MillBox is concerned right now, I can go ahead and move forward. However, I'm going to just do a couple of features of these hotkeys that we had discussed at the beginning. So for example, if I do some Control and E, what will happen is I can hide my fixture or I can make my fixture present. If I use, for example, the button, the number 9, it will give me some transparency and it will also give me some different rendering textures. If I want to go back, I simply press on 0 and it will give me back my opaque digital texture to it. So this is really interesting to know your hotkeys, because as you see, when you're dealing with cavities, when you're dealing with sintering protections, secondary axes, these are hotkeys that you can use. For the F features, which are the function features, you have different views from 5 to 9. So for example, if automatically I would want to choose F9 and move forward with a different view, I can go ahead and hit on F8 for a different view, F9 different view, F7, and then if I decide to hide my fixture, I simply go Control and E, and boom, right there, I'm back to square one. So as far as positioning is concerned, I think I'm ready to move forward with this particular milling toolpath. So what I'm going to do is I'm going to go ahead and save the toolpath. And the options appear. So for this particular case, what I would like to do is I would like to go ahead with 5-axis simultaneous cut. And I'm going to use my 3mm toric, which has been activated. So my toric burr is from Sierra Dental Tools. It's a 3mm one that we use for a variety of materials. I am not going to go with a roughing 2mm ball because I have the 3.0 active. And at the end, I'm going to mill additional details with 0.6mm ball, which includes what I have just painted on my STL. So when I'm comfortable with these choices, I can move forward and it will give me the option. Actually, before the finalization, it will just simply pop up a window confirming my position of my burrs. So once that window appears, then I'm going to confirm and move forward with the calculation. Now, the calculation might take a couple of minutes. So what I have done is I have done different scenarios. So one of the scenarios is the one that you saw with the painted areas as you see on screen. The different scenario is without the painted areas, just by default moving forward. Why I did that is because I wanted you as a user, and this I'm going to confirm so that it starts the calculation. I wanted to do that so that as a user, you will have an idea how long or how more it takes in order to mill something with higher and adequate strategy implementation. And for that, what I did was I simply took 2 screenshots of my calculation once it was done. And please pay attention to the 72.21 minutes. So these are two areas that I painted so that I can implement the 0.6 millimeter strategy. And for this particular acetal framework, it will take just a bit more than an hour at 72.21. However, and this is the fun part, and this is the important part, if I would not have chosen these two, and I would just say to myself that I don't want to waste time with this, I want to move forward, and I will be milling my two denture teeth on the bench with my handpiece, and I will not want to use this particular feature. Well, the difference is 2 minutes in milling. So as you see, this one is a 70.24 versus a 72.21 minutes at the bottom. So I think it's totally worth moving forward with these kind of features which MillBox offers so that you can be bang on your production. Like this, you know that your appliance is milled comfortably, adequately, and you don't have a lot of milling and grinding to do on the bench. So this is an important feature and a valuable feature from MillBox that is out there for all you users. So I would strongly recommend to just do those cycles, to go ahead and choose these features so that you can incorporate it in your production. Now, another fast track approach that I did was actually take snapshots of what it would look like with the designated area as well as the non-designated area. So this example per se is a screenshot of after simulation. So once your simulation is done, you can zoom in and you can see what you have done as far as the implementation of strategy. And I would like you to please pay attention to the wall that you see over here, as well as the quality of milling during the simulation process. And if I move forward with without the designated area, so this would be without it, please pay attention to what is happening with the wall. So this is the designated result, and this one is without the designated result. And if I put both of these onto my let's pretend that we're going to go ahead and we're going to put both of these pictures on one slide and draw a comparison. So I can go ahead and insert these two photos side by side so that we can see properly. So designated area and non-designated area. And if I minimize these two, okay, having a hard time with this. Let's cut this out. Let's bring it one by one while it's calculating in the back. So this is the designated pick. Here you go. And the second one would be the non-designated. So as you see, the wall is much more cleaner on this end, as well as what the strategy implements for rest of the material with a 0.6. And you see how rugged this surface is, as well as the wall finishing on this end as well. So this is a feature where everybody has access to. It's basically just a feature where you see with the tools on the left side and activates the designation for that milling zone per se. So once my calculation is done, I have the tendency to do simulation so that I can make sure that I have a decent texture to it, I have a decent result to it, as well as a decent, successful final product to it. So for this particular case, there's nothing more to add. I think with the choice of acetal for an immediate denture, what we can do is we can use also um, uh, we can use stain and glaze techniques for photopolymerization. A company like GC has their product line for photopolymerization um, stain and glaze kits, which you can reach out to your sales rep in order to get more information on it. And also, one last thing that I promised you I was going to show was the feature of customization. Now, for those of you who are not really familiar with MillBox, you have some options to reach out to your support specialist or your CAD/CAM specialist or even the vendor and request some customization. What you can do is, as long as you know what you want or what you do not want in MillBox, you can just jot down a list and have that discussion with our Zahn dental support agent so we can enable or disable. Just for fun purposes, what I'll do is I'll stop this calculation and I will go ahead and enter my dealer options as we move forward. So for my dealer options, I can go ahead. Okay, let's cancel this out. Okay. So as you see, dealer options gives me the opportunity to actually move forward with different variety of customization. For my particular MillBox, I have my materials listed right here. And then on my machine side, I have these machines that I have also listed. For my restoration types, these are the restoration types that MillBox has approval of using. And what I want you to focus on are the blocks. With my acetals, what I did was I created an acetal format, an acetal category using the PMMA approach. So as you see here with my 20 by 98, I can go ahead and click on my edit, and it gives me the opportunity to enter that specific PMMA acetal material in order to customize it. Well, the standardized way of working with this acetal is basically just follow the manufacturer's instructions. But if you would want to choose your color scheme, for example, you can go ahead and change your color and just approach it towards whitish or yellowish or even beige, ivory, whatever you feel comfortable with. And from there on, you can actually have a variety of top color and bottom color. So for multi-shading, you can definitely choose multi-shading for that specific material. Now, there's so many materials out there, we can't really generalize with colors and tints. But for example, during my preceding presentation that I did, I used a Keymail material from Keystone as well to actually customize my denture block. So this is something that you can request with your support agent, and we'll gladly do this for you. As far as moving forward with quick mill presets, nothing to talk about here related to our today's demo. For configurations purposes, what you can do is you can also go into configuration, and if you choose to go into configuration, it will give you the options to stuff like changing the template of your report, as well as changing the auto feature of your support pins. I personally like having control on my support pins versus automatic placement of my support pins. So I don't know if you noticed when I imported my STL, support pins were not automatically populated. So that's a feature that you can actually work on within your configurations of MillBox. And like I said, if you require any kind of extra training or extra visibility towards that, please go ahead, feel comfortable, call our support line, and we'll gladly do that for you. Now, as far as this acetal in production, what I can do is I can bring a case from this morning, and we can go ahead and simulate that. and we can definitely see the results, the end results. So for this one per se, which is the same case, yeah, so simulation, I think it's going to be a bit of time consumption. As far as results, this is what I was looking at. I was looking for a comparison, direct comparison. And for that comparison, I think at this point, it goes a longer way when you see the difference with images. So for any other questions or any other topics regarding Mailbox, Acetal, 3-shape modules, please don't hesitate to reach to our CAD/CAM specialist. I know this went quicker than the actual CAD design that we had done during part 1, but there's also different options for you depending on the license that you have. There's different features in Mailbox, so that's why I really invite you to go ahead and go to the support site from System USA, and there you will have multiple informations, accumulated knowledge base for you and your team in order to improve your CAD/CAM production on a daily basis. So as far as this particular demo and presentation is concerned, I think I'm okay with the information that I communicated. And as always, we're here to help you. Please reach out to your sales rep, representative, or CAD/CAM specialist in order to get some extra information. And at this point, if there's any kind of questions, please feel free to type in so that we can attend those questions.
What is the minimum version of Mailbox?
So right now, that will be the one that I'm using right here. So if I go, oh, that's not what I wanted to do. So there's a couple of versions. The minimum would be the basic comfort package, and that would be something to discuss with your CAD/CAM specialist, and that will give you an option to see what the breakdown is. Now, if you permit 2 minutes, maybe I can have something here on my screen to see the difference of So Mike Webb was joining, so 2020 minimum and 2021 preferred. There you go. And that's what I was looking for as far as the version itself.